Good morning, everyone. My name is Dinesh Vishwakarma. Today, I am presenting on topic pattern-based software design. Software design represents the critical bridge between customer requirements and functional implementations. So, it's basically the process of defining the architecture, data structures, interfaces, and components. A good design works like a roadmap. It reduces errors, makes the system easier to maintain, and makes sure the final product matches customer expectations while also being flexible for the future. So now, what exactly is pattern-based design? It's an approach where instead of solving the same problem again and again, we use solutions that have already been tested and proven in real projects. This gives us three big advantages. First, we get proven solutions that we know it will work. Second, we follow a structured approach instead of randomly coding. And third, it saves time and improves the quality and reliability of the system. Now, why design patterns are so important? They help us quickly identify problems and solve them faster. They make sure the code looks consistent across a project, so it's easier to understand and maintain. They also improve communications because developers use the same vocabulary when discussing designs. And lastly, patterns can be reused across multiple projects, which saves effort and keeps quality high. Every design pattern consists of several interconnected elements. Some important parts are the context, why the pattern should be used, the problem, what issue it is solving, the solutions, the structured way to solve it, the design forces, things like performance or maintainability that affect the choice, and the implementation characteristics. It tells the actual classes and responsibilities which are involved. So together, this makes the patterns complete and very useful. Thinking in patterns. Thinking in patterns means not just coding right away, but first looking at the bigger pictures. We try to understand the context, identify recurring structures, and then apply the right patterns. So the steps usually goes like this. First, analyze the context, then build the architectural foundations. After that, refine the components step by step, and finally, apply UI patterns to make it user friendly. So in this way, the design is built systematically from small parts to the full architectures. Pattern-based design process. The systematic application of patterns follows the structured methodologies that ensures comprehensive coverage from systematic architectures to detailed implementations. So the whole process of pattern-based design can be broken into 6 steps. First, do a requirement analysis to understand what the system needs. Second, break down the problem into smaller subproblems. Third, apply architectural patterns to define the overall structures. Fourth, use components level patterns to define subsystems. And fifth, apply UI patterns for a consistent and user-friendly interface. Finally, do quality refinement to improve performance and maintainability. So these steps makes the design complete and reliable. So now let's look at the main types of design patterns. There are four categories. First is architectural patterns. This defines the structure of the whole system. Examples are MVC, layered architectures, microservices, and event-driven architectures. Second, creational patterns. This deals with the object creations. Examples are singleton, factory method, abstract factory, and builder. Third, structural patterns. These organize relationship between classes and objects. Examples are adapter, composite, decorator, and facade. Fourth, behavioral patterns. This manage how objects communicate. Examples are observer, strategy, command, and state. So pattern-based design provides several key advantages that improve the quality, efficiency, and reliability of the software development. So first is reusability. Proven solutions can use again and again. Second, faster development. Teams don't waste time solving the same problem. Third, better quality. Patterns are tested, so they reduce bugs. And fourth, less risk because we are using trusted approaches. So despite its advantages, pattern-based design also has certain challenges and drawbacks that developers must be mindful of during implementations. So we need to expertise to choose the right pattern. If we overuse patterns, the system can become unnecessarily complex. And finally, patterns are context sensitive, so they must be adapted to the situation and not applied blindly. To wrap up, pattern-based design is about balancing proven methods with creativity. It helps us build scalable architectures that can adapt to new requirements. It makes systems more maintainable because the designs are clean and modular. It saves time, reduces errors, and ensures consistent quality. So overall, pattern-based design is very powerful way to achieve engineering excellence while handling complexity. Thank you.